last but certainly not least, we have Frank Weber. Frank is the vehicle line executive and the global chief engineer for eFlex. And the way we're organized in General Motors is we have a series of vehicle programs, and these programs are led by a vehicle line executive along with a cross-functional team. So it's Frank and this group here, as well as other members, that are the ones that are really doing the work on a daily basis to bring the Volt to life. And with that, I'd like to have Frank come up here and share sort of a brief status report on where we're at. Frank?
A brief history also to myself here. Somebody called me, it was end of February last year, and I remember it was an evening and I was walking with my wife around the neighborhood after it was a Friday evening. And it was actually my former boss back in Europe, and he said, I think there is a plan, we have something for you. They do a program, and this program has a new propulsion system and is the Chevy Volt. Have you heard about this? And I said, certainly, I've seen it in the US. And he said, would you be interested to run this program? And my response was, within seconds, yes, I'm absolutely willing, and I want to run this program. And what you learn is I would say, unprompted reaction, yes, I want to do this, turned out to be the right decision. And what we learned over the last 12 months now on the real development of the Volt is typically what you see when you introduce new technology. What you see is that you are raising more questions. You are asking yourself, was the initial concept right? Have we considered all the aspects of that concept? And I can tell you from all the data we have generated over the last 12 months, the more data we see, the more confident we are that this technology will fundamentally influence the automotive industry. There is no other technology like the extended range electric vehicle that will really have the power to fundamentally change this oil consumption pattern that we currently have in vehicles. Hybrids are important to improve efficiency, but still you will consume oil, and therefore an extended range electric vehicle will be the only solution that drives, I think, a different pattern and energy diversity into your daily driving. Now, I would like to give you an overview. What is the insights that have been generated over the last 12 months, and where are you? And I can understand you probably have seen all the skepticism that came towards us. People came and said, this is just a GM research project. This is just something they do because they want to continue to sell large trucks. I can guarantee to you that the Volt is much more than just a car program. The Volt in this organization is really remarkable because it is also a symbol for the cultural change in the organization. This program is not risk-free, and we know this. This program takes leadership on all levels in the organization. And by the way, the reason why we are here today is we are looking for dialogue on all levels. Dialogue amongst leaders, dialogue amongst the industry, dialogue between, I think, between functions, and also dialogue between customers. What are the expectations? What is creating, at the end, disappointment? What is creating excitement? I can guarantee you there is nobody who has the final answer. The current project and how we are running it means we have open channels. Open channels are important because with every development step, you will see we learn something. With every development step, we are asking ourselves, what is now the direction we have to take for this program? Now the key and the backbone for the car is battery technology. We wouldn't be here today to say that this is now a production engineering program if we hadn't had the confidence that the battery technology has in the meantime matured enough that lithium-ion cells will have the capability and the energy and power density to fulfill the promise of the 40-mile electric range. We have done enough tests in the meantime to see that the cell performance and everything we see and the cycling time allows us now to go into automotive applications. The pictures you see behind me are significant, so they are small for you to see. What you see on the right-hand side of the chart is a pouch cell, a prismatic cell, and this is This is the foundation for the battery. So we are using lithium-ion chemistries that are fundamentally different from chemistries that you see in consumer electronic devices. And the chemistries and the cell itself has been tailored with the two suppliers we are working with for automotive applications. Now the challenge is no longer on the research level. People come and say, what do you do on the chemistry level? Are you still working different chemistries? I can give you the answer. We have robust chemistries, and we have only chosen robust chemistries because the true development now is not to find new chemistries. It is now to have a stable and proven chemistry and turn those individual cells into a reliable and robust battery pack. And this is the true challenge we have in front of us for the next 2 years. So what you see in here is we took the cell. Our pack has roughly 250 cells. The one solution of the supplier of the one cell is actually having a little bit more cells. The other solution has a little less cells. But basically, we are now taking those cells and arrange them in blocks and modules into that packs. The packs is a liquid-cooled pack. And the first pack has arrived already October 31st last year. So we are receiving packs, and we are creating insight on those packs. What you see in the middle here is Lance Turner, one of our engineers. He is responsible to generate cycle time. So he has those packs sitting in the lab, and he is running tests with those packs and with the cells to really generate learning as quickly as we can to see how the individual cells behave in this large battery pack. The whole industry has nothing that is comparable to the pack that we are introducing into the Volt. It's 16 kilowatt hours of lithium-ion energy. There is nothing in the industry that has that size and that technology. And by the way, also by the time we are on the market, you will not see that there is anything like this in the market. So it is important for me that you see we have those packs, and what we do currently is we are preparing those packs for vehicle applications. It is very critical that cycling batteries is important, but seeing how those battery packs behave in vehicles is the next real key step. So we are preparing, if we go to the next slide, what we are doing, we are preparing the vehicles, we have vehicles ready to run and to receive those battery packs. Within the next weeks, we will actually assemble those packs into vehicles. What you see here is so-called new vehicles, vehicles that are there to demonstrate capabilities, technical capabilities. And this is what you see is on the left-hand side, the underfloor configuration, and the black piece is the battery pack that goes into that underfloor. Then you see one of our engineers working in the engine compartment. What we are already doing at this point in time, and we are simulating battery packs, we are working on regenerative brakes, we are working on chassis, we are working on the basic calibrations, we are doing software work already at this point in time. So what this is showing here is within the next weeks, we will have the production intent packs going into those cars for testing. This is a very, very important step for this program here to generate all the insights. Last chart that I want to show you in some of the pictures is propulsion technology is important and is key to the success of this program. There is no doubt that we can achieve the 40-mile electric range and will satisfy that side. But what we have learned throughout the Detroit Motor Show is it needs a propulsion technology, but it needs also a highly attractive vehicle this technology goes into. So while we are doing now all the, what we call the critical path development of batteries and propulsion technologies and electrification of the car, we are at the same time working the styling of the vehicle. You see some of the work that's been going on in Tim Drake's studio here. People that are doing the interior work. What you see in the center picture, it's relatively small, is seating bar configurations to show us what is the comfort that we achieve in this car and the roominess. You see in the very far rear, you see the full-size clay model standing there. And what we are doing within the next days almost is we are signing off the final production design of the Volt program. And this is all happening in parallel.